Hello, everyone. Let's get started. Okay, thank you for joining us today. We are honored to have Katrina and Glen. Today, they are both CCOM alum, so I think that's a very good thing. And they will be talking about coverage for navigation, and which is the National Bathymetric Source Program. Before I pass it on to them, I'll just quickly read their bio. Katrina Wyllie currently serves as the operations team lead for the NOAA's National Bathymetric Program. In her prior role, she served as Chief of Service Section at the U.S. Army Corps of Engineers, New England District. She has also held positions with NOAA's Hydrographic Service Division Operations Branch and the Atlantic Hydrographic Branch. Katrina holds a Bachelor of Science in Marine Biology from the College of Charleston and a Master of Science in Health Sciences from the University of New Hampshire. And Glen is the engineering team lead for the National Bathymetric Source Program. Previously, he supported NOAA hydrography in the Integrated Ocean and Coastal Mapping Program, and also as a NOAA officer aboard NOAA ships Fairweather and Wood. Mr. Wise has a BSc in physics and an MSc in ocean engineering. Please join me in welcoming Glen and Katrina.
So why don't you start?
Oh, I was like, I'm starting? Okay, I'm Katrina Wyllie. Thanks again for the opportunity to present today. I'm the operations lead of the National Bathymetric Source.
And Glen, as I said, I'm the engineering lead. So I'm going to start us off, just do kind of an overview, introduction of the National Bathymetric Source Program, what it is we do, then maybe dip my toe a little bit, maybe open the can on interpolation, what we do, let Katrina take that can, dump it on the floor, sort through it with you all, and then I'll close up at the end. So without further ado, so we work for the Office of Coast Survey, which our primary mission is to create safe navigation products. The most notable of which is, of course, the navigational chart, so which is what you see here. But our piece in that puzzle is to provide the bathymetry that goes along with that. So all the soundings or contours that help navigators decide where they can go and not go is basically what we're providing and contributing to the navigational story. But we do more than just provide navigational products. In addition, we also provide data for the public. So this is Blue Topo, if you might have heard of that. We also have a couple other pipelines, some of which go back for project planning. So for a variety of purposes. The real difference between like those navigation products and those public products is the kind of data that we include in them. So we try to make sure that we always include our qualified data and our precompiled data. So this is data that normally follows through hydrographic pipeline where it goes to our branches. They look at its quality, make sure it's cleaned up and ready for use. But then precompiled also includes things like the old navigation chart, making sure we pull in the old soundings. But our public product also include unqualified data. So this is data that hasn't really gone through the full hydrographic process, but we feel like is important to get back out to the public. If nothing else, it helps make people feel like their contributions to the project, to Coast Survey, are being used and not stuck in a queue somewhere for an extended period of time. So this is a general overview of what our workflow looks like. This is a slide I've been flogging for about 8 years now, so some of you may have seen it before. On your left-hand side, you see kind of the various sources that we pull our data from. So we pull in our own data, of course, but then like Army Corps of Engineers, University, we certainly have data from UNH in our compilation, as well as other sources. We take that data and we prepare it. So that basically means we try to make sure it's all in the same, a common vertical datum, has similar metadata to support our combined process. Interpolation, of course, is an important part of that process, where then it feeds into our combined engine, which then takes the right sources and puts them into the various products that they need to go in. So the top two there are the navigation products, the electronic navigational chart. The precision marine navigation is S102 if you're thinking about the future of navigation, and the S100 framework. Planning is our internal pipeline, modeling Blue Topo are our public pipelines. So this is just an example of the kind of information we like to make sure that we carry all the way through that process. Different people give us data. At the end, you should know where it came from. So we're going to talk a fair amount today about metadata and various ways you get at it and what its meaning, various meanings are. So I just wanted to highlight on your left there, you see the bathymetry as a color map, and then more central, you see the various sources as contributed by a different color. And so the primary navigation products that we're really here to talk about, since that's the primary purpose for our program, is the data that we provide to the Marine Chart Division. So this is data that's on chart datum and is ready for navigational use. We extract it from our process and send it to the Marine Chart Division as geotiffs, as well as soundings, and we also build additional products that support the chart, like MQual, which is an assessment of quality by area, and other kinds of things like chart comparison. The S102 product is the future of navigation and includes a lot of that same information, but basically is part of a new format that's built on top of HDF5. So this includes a number of rasters, as well as a contributor layer that carries a lot of the metadata we're going to talk about today. I don't really want to get too much into our public products since I want to focus more on navigation today, but since we're talking about metadata and how it gets carried through our process, it's important to note that we carry the same kind of information in our public products through geotiffs and raster attribute tables. So just to continue our brief overview here of the National Bathymetric Source Program, we have a number of areas that we've already assembled all the bathymetry we can find, and we're generating that, putting it out in all of our pipelines. As we get it, we create new products. So primarily right now, that's like the East Coast, the Gulf Coast, and we have Southeast Alaska as well. And so we're putting those out more or less we're trying to get to weekly everywhere with the goal eventually to be daily to make sure that our navigational products are up to date for the mariner. But by the end of this fiscal year, so in the fall, we plan to have the West Coast done, and then the rest of Alaska, Pacific Islands in subsequent years. So if you wanted to use this information, we actually just yesterday put out a new package that helps you download the data and use it locally. And so just wanted to highlight that here. I gave it to Larry earlier today, and I haven't heard any complaints, so I'm sure it works perfectly.
I told him if I could use it, anybody could use it.
So, yeah, thank you for testing it for us, Larry. I appreciate it. So we're hoping that this will make our data more accessible. So if you have access to this URL here, please feel free to go and give it a try. All right, so we're going to get into coverage for navigation, which is really what this talk is supposed to be about. So we're going to go back to where we were previously, back to, I think we're outside Savannah here, and we're going to zoom in on a specific spot and say, all right, well, what does the bathymetry there look like? This is the same beautiful, seamless bathymetry that we were looking at earlier. But if you start twiddling some of the knobs under the hood, you can get as a view of where we have interpolated data and where we have real data. So the measured bathymetry is here in blue. You can see it really doesn't constitute a significant portion of the seafloor in this area. A lot of it is, in fact, interpolated. And so really what that should tell you is if you're going in and out of a lot of our major ports, you're navigating on interpolated bathymetry. And that's for a number of reasons. So another region here, this is specifically the Mississippi, which is one of the most important places navigationally in the United States. You can see on the right there a graph that shows the change in the bathymetry over time. So this is an area that, there's lots of sediment deposition, there's lots of sediment moving around so that the seafloor changes significantly, and that's really important navigationally. So if you have a survey that goes through and you have a full coverage survey there from maybe 10 years ago or so, and then it's followed up with a partial coverage survey, you end up with this funny combination that doesn't seem to make a whole lot of sense because the seafloor has changed significantly. Those color maps are actually the same. And so where the color is significantly different with the smaller areas, that means the seafloor is significantly different. So if we compile this and put this out as a navigational product, it would look something like what you see there on the right. You can't navigate that. That's not meaningful information for the mariner. And so this really gets to the fact that we often survey locations. We go out and we measure depths in discrete locations, but we have to navigate areas. You can't navigate just where the bathymetry has actually been measured. So what is the purpose of a survey? Well, it's obviously to support navigation, which means you need to have a sense of what the bathymetry looks like over an area. But a lot of surveys are designed to be systematic, to capture the seafloor morphology in a meaningful way so that you can do some form of interpolation. If you look at all the charts that have ever existed, there's significant data on them that is in fact interpolated. It's just that it's a contour that somebody hand drew that gives you a sense of continuity. If we do that interpolation between those various sources, you can see you get a much better product here. There is a spot, I'll just do it to help support those online. Right here, which is right here. You can see this is still a spot where there's old coverage that's coming through from a full bottom coverage survey, and then subsequent interpolation and then set line spacing surveys didn't quite match up here. And so you're left with a gap, and we'll touch on that more a little bit later. So I'm going to hand it over to Katrina.
All right, going to get into interpolation. I'll show you a lot of pretty pictures and talk you through it. All right, so which types of surveys are interpolated? What are we looking at? So first of all, not systematic, or surveys that, if it isn't systematic, it isn't interpolated. So if you're looking at things that aren't adequately representing the seafloor morphology, we're not interpolating them. So that's very commonly your reconnaissance surveys, your transit surveys, some external source data where they, it's data of opportunity and they just went out and collected data and provided it to Coast Survey to use as we can. So if it's not systematic.
Formal definition of systematic survey, does NOAA say a systematic survey is one that consists of with certain criteria?
Yeah, so it's the word systematic surveys in the S57 table for like coverage, and it says like controlled systematic survey, typically for CATSOC B surveys where you don't have full bottom bathymetry, but you do have a systematic survey. And then there's, we'll get into it. But
which IO specs do all the time.
Right, so then you're talking about specs, and so NOAA Coast Survey has approached this with a very clear specification in mind for like how far apart your lines should be when you go and approach a survey, and should you do bathymetric splits, and we'll touch on that a little bit as well. So it's by systematic, we are defining systematic in those project instructions that we're telling the NOAA field units and the NOAA contractors to then go collect. Speaking of, so NOAA surveys. So we have bags, bathymetric attributed grids. So around 2000, early 2000s to today, that's the typical format they were receiving bathymetric data. And then we also have pre-bag data that are from NOS surveys, and these some National Ocean Service, like Coast Survey surveys. This is typically not full bottom, full bathymetric coverage. And so you see on the left, that's in purple, those are all the bags for this area. There's a little less than 3,000 in that picture. And then on the right, you've got what we call colloquially in the project Bathy point store. So this is the pre-bag data. And the little blurb on the bottom is exactly what's in the specifications, the NOAA hydrographic survey specs and deliverables, section 6.6 coverage. This has been in the specs since, Coast Survey started. It's if you see something that is not accurately representing the survey, go collect more data, do a split, do additional data collection, and decrease your line spacing to actually represent the survey that you are, the seafloor that you're collecting. So if we zoom in, keeping that same purple and yellow color, this is off the approaches to New York, and you can see there's some modern bags. So there's some purple data, and then there's some yellow. So this is some pre-bag data. This data could be lead line, it could be single beam. It's possible it's multi-beam before it was routed into a bag. And then these are the ones that, if it is systematic, we are interpolating. So every pre-bag NOS survey, our team is investigating. We're looking to see if it's systematic. And then if it is, we are interpolating. So the metadata for that, the actual, and this is now into the S100 metadata, we have coverage and bathymetric coverage. So coverage is true if it's systematic. But if we're doing the interpolation, the bathymetry coverage is false for that interpolation because you don't actually have a measured depth there. So what does that look like? So this same area, very colorful. You've got 6 different surveys that fall in that little area we were looking at. There's some 1930s data that is not full coverage bathymetry, and then you have some 1975, which again is not full bathymetric coverage. And if you look at them together, they overlap. And so just like that Mississippi River survey that Glen was talking about, if we were to just grid this, you would have all sorts of points coming through. And that's a 40-year difference in time. And so the seafloor has changed. It's not static here. And so what we do is to understand the survey is we're doing the interpolation of those individual surveys. And so these are the 3 1975 surveys, and we're doing the interpolation. And so on the right, you can see the source data. The points are on top of the interpolation. And you get an idea of what the seafloor was at that time. NOAA surveys are not our only source. We mentioned one of the other sources that we bring in are Army Corps of Engineers surveys. By default, they do systematic surveys, right? That's kind of their mission. They're looking to see what's the condition of this federal channel. And they might be doing condition surveys, they may be doing dredge surveys, but by default, they are typically doing a systematic survey of that river. So this could be single beam, multi-beam. Sometimes they throw some topo data in there as well. This data is all on eHydro, which is the place that we go and grab the data from. And if we go back to Savannah, the first picture we're looking at, the entrance to Savannah here is, this is a systematic survey that is not full bathymetry. So on the left, you have the actual source data, the track lines that they've run. And then on the right is the interpolation we're doing for that survey. So we look at all of the Army Corps surveys that come in. If it's systematic, which majority of them are, they get interpolated. Oh, I want to make a note. There's different districts. There's like 20-something, 23 coastal districts, I think. And different districts have different capabilities, different sonars, different environments that they're dealing with. There's a lot of set line spacing surveys like this in the Gulf, but there are also a lot of districts that are doing full bathymetry surveys. These examples, you've got the New York district. This is off of Brooklyn. The next one over there is off of Norfolk, if anyone's watching from Norfolk. You got some Jacksonville data off Florida, or Jacksonville district data off Florida. And then this is off Kittery, a recent data that the New England district did. And so you do have some full bathymetric data coming in, but the ones that are not, that are partial bathymetry, we do with the interpolation for. Okay, so we talked about systematic. The next type of interpolation that we're doing is when we have side scan sonar. So something that NOAA likes to do to be more efficient is when we start to get to areas where it makes sense, we will assign what they call skunk stripe or concurrent bathymetry with side scan sonar. And so this is very spec'd out where you are doing object detection, side scan sonar. So you're looking for certain size features. If you're finding those features, you're running developments. If you're seeing changes between lines, you're running splits. If you have a holiday in your side scan mosaic, you're running a fill with either additional side scan or bathymetry. So these are, again, very spec'd out, specific to find features, but you're not getting full bathymetric coverage, right? Where it's deeper, you might have full bathymetry. If it's like a super rocky area, you might use full bathymetry, but to get more area and still have feature detection capable surveys, this is a very common method that is employed by co-survey. And so the interpolation that is done between those areas of set line spacing, which is not full bathymetry, is systematic, right? So it's coverage true. Where we interpolate, it's not bathy coverage because we're interpolating, but it is feature detection because we are identifying features for that area. I have a little asterisk there for features because sometimes we get external source that's not spec'd out and people are running side scan and maybe it's for habitat, right? Like that's another great use of side scan. But if they're not doing that additional developments like identification of contacts to then go develop that kind of thing, it's not necessarily feature detection. So it's very common for us to get side scan sonar, not very common. It's common, sometimes common for us to get side scan sonar when it's like a habitat mapping cruise, but if it's not feature detection, we aren't calling it feature detection true if we do that interpolation. So what does that look like? Here's a beautiful survey that just came in off of a couple months ago. I think this is off of Maryland. You've got your project instructions that went out for this survey, and it said in, between 3 meters and 5 meters, run concurrent bathymetry and side scan sonar, and then deeper run full bathymetry. And so that's where that line is. That's where it splits off. And then you can see the side scan sonar collection on the right. And if you look, you can see there's development. I guess I can go on the slide. This is that same survey. There's additional bathymetry lines that are being collected for developments, or when they see a contact or something, or if they do additional bathymetry between lines. So we interpolate where we have that side scan sonar coverage, that object detection coverage, and then you can see the two of them together. So you have the full bathymetry, you've got the set line spacing, you've got the interpolation behind it. All right. And then the third example of how we interpolate within surveys is for resolution. So this is what we call upsampling. So this is an example off of Long Island where another beautiful survey. It was delivered in multiple resolutions, so depth thresholded based on the specification. So we got 1 meter, 2 meter, 4 meter, and 8 meter surfaces. In this area, we're making 4 meter products. So having this little deep hole that you see on the bottom there in an 8 meter resolution is not going to support a 4 meter product, right? You're going to get gaps, and that's not going to be a meaningful product to show that's the seafloor there from that survey. And so we do an interpolation to get to a 4 meter resolution. And so we take that 8 meter, we upsample it, which is just an interpolation, to 4 meters so that we can have a 4 meter product. And so the same metadata, it's systematic, so it's still coverage true. The bathymetry coverage, since it's interpolated, is false. And then features is true in this case because the source data was feature detection true. And so it keeps the same feature detection and the same feature size. It's possible that, especially for like external source data, you might get like a 10 meter survey, but it might not be feature detection. So it would have coverage true, Bathy coverage false, but features false. It just really depends on what the source data is for that feature metadata. Okay, so we talked about the interpolation for these individual situations that we run into, all the surveys that we're bringing in. So systematic surveys, surveys that have side scan sonar collection concurrently, and then upsampling. But how do we relay all that metadata into the products? And so Glen touched on this with our pipelines. We have navigation pipelines that have this additional metadata provided on the node level. So S102 has that contributor layer. It's the same information that's in BAG 2.0 and the same information that's in our geotip with our raster attribute table. So that means when you do the compilation of bathymetry, you click on a node, you can understand, does it have Bathy coverage true? Is it coverage true? Is it features detected true? Like all of that is being provided on the node level. And so for the interpolations that we're creating, here's your options for that interpolation. Coverage is true because it's always systematic. Bathy coverage is false because it's interpolated. And then features can either be true or false. It depends on the situation. If it's side scan sonar, that's feature detection, it'll be true. If it's not, it's false. So this node level metadata, we're going to just touch back on our 3 situations and kind of look at what that looks like see what that looks like for the products. So going back to our 1975 surveys, right? We interpolated these are off the approaches to New York. So you see the 3 1975 surveys, and that's the product for this area, right? This beautiful continuous surface. If you look at the metadata and color by the different attributes, you can color by the individual survey files that make up the best available bathymetry here. And so our 1975 data ended up as this purple color, this other color, and this light green color. So there's other, this little accordion bag is on top. There's some other bags that were on top of here. There's this not systematic survey also offshore. So if you look at the Bathy coverage, and this again on the node-based level, what is true is in that blue color, and what's false is in red. So there's little dots all over this red where you actually have the points of where you've measured your bathymetry, but the majority of it is showing up as red because we have to interpolate to show the coverage of those 1975 surveys. Take a look at some more metadata. You can look at the uncertainty layer. And so again, where you have some more of those modern bathymetric Our bag surveys, they're in a lighter color because they have lower uncertainty. As you get deeper, darker reds, your uncertainty is increasing. And then features, so feature detection. These surveys did not have side scan with them. These were just single beam surveys from 1975, systematic single beam surveys. So feature detection for those are false. So, you know, what's interesting here is you do have this little accordion survey. This is an external source survey. So it had great uncertainty and it had bathy coverage true, but it was features false. And so that's something that, oops, pointing my laser at you. That we are capturing as we move to the S100 metadata is that all of those metadata attributes are collected individually. So you can have great uncertainty, you can have coverage, but you could still be features false. That's allowed, that's okay. And that's the case that happened here, but the ones that we were looking at from 1975 are also features false because they didn't have object detection capability. Okay, our second example, what does it look like on the product? So this was our set line spacing with side scan sonar off of Tangier, Maryland. And so if you look at that together with the best available bathymetry today, and we'll take a look at the metadata. So the survey files, the individual surveys that make up this, this patch of seafloor, you've got your dark blue here. That's where that full bathymetric coverage, the bathymetric coverage true data was, and then these two greens are where you have the set line spacing and side scan sonar. So the source data is always going to win, it's always going to be on top, and then the interpolation is behind it. So those are the three survey files that you're seeing from that example specifically. If you look at their bathy coverage, where you have bathymetric coverage true, it's in blue here, and then all of those individual lines are also blue because you had measured bathymetry. Again, this is important for like sounding selection, right? If you're picking soundings, you want to pick where you actually measured the depth. You don't want to be picking over interpolated data, which is in red. And if you look at our uncertainty, same situation, the lighter color is less uncertainty. This is all in the node base, so like these bags came with total propagated uncertainty on the node level. So we're showing you the uncertainty per node as it was provided. And so you've got your full bathymetric coverage here, and then you've got your higher uncertainty in between the source data. And then in this case, features are true because we had that object detection side scan sonar, and so this whole area is features true. And then our final example was the upsample. So this was that area where we had the 1, 2, 4, 8 meter surfaces and the little 8 meter hole. We had to upsample. So this is what it looks like for the bathymetry in the area. And if you look at the individual survey files, you can see that yellow pops right out as the area where the 8 meters is, that we upsampled to 4 meters. So where there is 8 meters, that data is coming through, and then where it doesn't support the resolution for the product, the 4 meter interpolation is coming through. And so that's why you see this bathy coverage red hole. There's little blue dots you can't see where the 8 meter resolution is coming in. And then same thing, uncertainty is a little bit higher where we did that interpolation, and features is true because the source data in this case had feature detection capability. Okay, so we talked about how we interpolate different situations within surveys. So we look at every survey coming in, be it external source, NOAA, Army Corps, whatever we're getting, we're doing an assessment for systematic true false. If it's systematic, we interpolate. So this is a reminder of our workflow. We bring data in, we process it, we interpolate on every survey level if it's systematic. And then we do the combine. And so then after the combine, the second phase of interpolation in the NBS is to do a generalization. So that's to fill in any remaining gaps. So if surveys don't junction exactly and there's no other data behind it, we need to have a continuous surface so that we can get contours from our data and depth areas, right, for the cartographic product. You need a continuous layer to have those cartographic features derived from. And so that generalization, NBS generalization, is its own thing in terms of the source survey file that's you'll see in a second, but it's coverage false, bathy coverage false, features false, right? It's basically, if you know CATSOC, the category zone of confidence, it's D. It's like the lowest CATSOC you can get. We don't know what's there, but we need a complete surface. So we do a second interpolation. And so what that looks like on the left, right here, is just an area of where we've done a combine. And you look on the survey files on the right, where it's black, we've colored the NBS generalization, right? The surveys didn't quite fit together. And so there's a gap. And so we did an interpolation to cover that hole. If you look at the Bathy coverage, again, red is false. So where that gap was is false. And then the uncertainty is wicked high right here. So you can also see that same gap is coming in. Okay, now it's your turn.
So, interestingly though, coming back to this spot that we remarked on earlier here in the Mississippi, where there's a gap between different regions. So this is an area where we wouldn't have generalization because we had data that was full coverage there before. So this is an interesting case that we actually run into fairly frequently. So this is in Charleston, where we've gotten a lot of reaction from pilots, in fact, who keep seeing this little gully that shows up periodically, depending upon the Army Corps survey. It's in the corner of, I think it's a turning basin, right? Yeah, it's a turning basin they have in Charleston. So this is real life mariners trying to use our products. And if you actually have access to the underlying metadata, you can see that this gully happens to be the result of this orange strip here that runs right along the edge. So the Army Corps went in, they did a full coverage multi-beam survey, and then they went back and did, as it had filled in, and did this condition survey where those are the green lines there, and then the pink is where we have interpolation. And that leaves this gully on the side. So this is an interesting case. Like, what should the NBS be doing there? Should we be extrapolating out beyond the edges of our survey, or should we be taking the best available bathymetry we have and saying, this is what we have? And is it incumbent upon the Army Corps or wherever the provider is to make sure that they're junctioning their surveys with the adjoining area in a way that's meaningful to their customer, in this case, the mariner? And so just a really interesting case. And so I think what a really important part of that story is to make sure that we're also educating our users to ask the right questions. Fortunately, CIQ, which the pilots happen to use there in Charleston, has just updated their products to be able to visualize that layer in S102. So the pilots can now see that orange strip and understand, hey, there's a gully there for a reason. It's a different data source. Historically, they've always taken in, various XYZ files as provided by the Army Corps of Engineers, and looked at the source of those soundings and said, well, this is the date of the survey, so therefore this is the newest data, and so therefore this is what I have. It doesn't really work when you're going from a sounding, kind of generalized concept of navigation to high resolution, like we're talking about here. The data just needs to be at the resolution to support the products. So with that, in summary, I think we've made the case that interpolation is really important in our navigational products. I think we've made the case that it's important to interpolate within a survey so that that survey properly represents the seafloor at the time it was there, or at the time it was conducted. But then we also need to do a generalization between various surveys to make sure you have a sense of complete coverage, because we need to transit areas. We do not just work along where we've actually measured depths. But it's also really important to educate users on the information that we've made available in our various products. So with that, I'll say thank you.
Yeah, Larry.
No, that's great. I'd love to see the progress that's been made. You've come a long way. One thing I don't, unless I missed it because I was a couple of minutes late, I don't think you discussed how you interpolate. What's the methodology of interpolation? Is it spline, kriging? What are you doing?
So you can see Elias's thesis. So we do a linear interpolation, and this is really in anticipation of his PhD, which is to say what's an important part of the interpolation story is not just the depth that you report, but the uncertainty that goes along with it. And trying to estimate what the uncertainty should be for that interpolation is a difficult task in and of itself.
Or the PhD thesis.
It happens to be a PhD thesis that hopefully will be completed really soon. But the interpolation itself, we do a linear interpolation because we feel that has minimum impact on the stationarity of the statistics that go along with trying to estimate the envelope around your estimate. You're doing all kinds of funny splines and things. It becomes really difficult to say, And this is your uncertainty that goes with that estimate. So we do a tinning, we do linear interpolation. It's not always the prettiest, but we feel like it's the most honest.
Between point to point, or do you have some weighted,
It's point to point.
this point to point? Okay, all right, thanks.
Yep.
Pete? Yeah.
My question was almost the same as Larry's, but I have a second one.
Okay.
Great presentation, really enjoyed it. So I wanted to ask you about the method, your interpolation method, which you alluded to is linear. I've got another question for you. When you've got different data sets, how do you change the factors on that linear interpolation, or do you keep them fixed?
Factors on the interpolation, meaning, can you?
Parameters that there's different parameters that you can use with the linear interpretation or interpolation.
So we're building a tin on the data, and we're doing a linear interpolation based on
With a
that.
tin, you can change the sides and you can change all sorts of things.
So the tin we're generating currently using Q-Hull, so it's a Delaunay triangulation. We don't do a lot of modeling with that.
So you're not changing the parameters between different data sets.
No. Nope.
That was my question. Because you can.
All right, no other questions?
Wow,
What's the distance within which or outside of which you're not comfortable interpolating? Like, how do you decide that?
So that is a great question. And
That's why I asked it.
Yeah, I wish yeah. So so that again comes back to Elias's thesis. Like I think right now we are kind of doing what we feel like is right, which I think is historically how it was done. The surveyor would go out and they'd measure in a couple of lines and then say it looks like it's showing in between, and that, you know, whatever made them feel comfortable, like they'd actually captured the geomorphology of the seafloor. So a lot of that older data, Katrina's team is going in and saying, well, you know, we think that it's captured the geomorphology here, we are comfortable interpolating, or we're not. But the uncertainty that then goes along with that estimate is then the hard part, because this gets back to when you're going to qualify a survey, uncertainty is part of that CATSOC qualification. So if it's going to be a CATSOC B survey, the interpolation between the lines you've measured actually needs to be underneath that CATSOC quality. And so that's why being able to estimate the uncertainty. So I think what that means is if you're in an area and you go out and survey, and the estimated uncertainty that's going to magically fall out of Elias's PhD says your uncertainty is too high, you go and run more lines to decrease the uncertainty so that you can meet essentially the specifications for the survey that you're doing. And I think that's the right way to solve that problem. But right now we're making it up as we go.
Well, there's also some situations where we have that older data that crosses like a channel. And if it's crossing from like the change in elevation is not keeping up with the uncertainty that we'd be interpolating, we would either increase the uncertainty for that part of the interpolation, or we just wouldn't interpolate where it crosses the channel, right? Like, so it is also like not just geomorphology, but also like anthropogenic. Like, we don't want to interpolate over piers. We don't want to do stuff like so we're trying to pay attention and clip our interpolation, but also provide as standard of a definition of systematic as we can determine.
So your rules are flexible.
What would you like to fix? Flexible.
Your rules are flexible.
The surveys are flexible. I think we see even within the project instructions that there's a range of how surveys have been assigned over the years. And so I think that's really coming back to Elias, is it should be quality driven. It shouldn't be flexible. It should be, here is the data and here's the uncertainty of that data. Either deal with this resulting uncertainty or go collect more data.
But we're bootstrapping a process built on data that was collected years ago without any of this in mind. So in that sense, bootstrapping is often flexible.
Yes.
Juliet?
Based on Eric's now getting some feedback from mariners, do you think that there's a need to encourage people to have like a semi-transparent layer on top of either channel bounds or survey bounds so they can see where the core is doing stuff? Because that's where
That's what we're getting.
navigators really want to see where it is and what that fresh data is, because they're used to having a lot of those pilots are used to having the channel overlays slapped on top of the chart anyways. So
Yeah, and I think that's really the power of that extra metadata layer, that contributor layer. And so being able to pull it up in HiPAC when you're surveying, right? Like you can pull in your S102 data and say, okay, I collected these lines, but oh my gosh, it was a meter shoulder last time. I need to go get another line or something. So having that near real-time background, I think is helpful because you have the metadata then to interrogate it. And so getting software to make that user-friendly and available to the different use cases, I think is kind of the next step to educate. Like you can go investigate this metadata. You can have it up while you're acquiring for your Army Corps survey and see that you've captured the change or you haven't.
Right. Is there any temptation to start using things like crowdsourced bathymetry to help with gap filling or interpolation challenges, and what are the pitfalls if so?
The pitfalls of answering the question? You setting me up?
Let me call Glen.
From my perspective, there's nothing special about crowdsourced bathymetry. It's another source of information that needs to be qualified and used where appropriate. So in that sense, if it fills in an interpolation gap because we don't have better information there, then that's what should be in there.
I guess one thing I'm worried about is circularity, because I've heard other people talk about using crowdsourced bathymetry for other things and perhaps referencing Blue Topo as part of that process. And so you get the weird, if you start making Blue Topo with crowdsourced bathymetry, people using crowdsourced bathymetry to process Blue Topo. Yeah.
I think as part of evaluating a survey, it's often good practice to compare it to what you know. And so I think more and more the NBS bathymetry is being used when new surveys come in to say, how does this compare to what we already know? And so in that sense, crowdsourced bathymetry evaluation against the NBS really isn't any different. It's just that the next step, like any other data, it would become part of the compilation if once it's evaluated and fully qualified, becomes part of the compilation.
I guess maintaining the provenance in the metadata.
Yeah.
So if you're going to do some analysis that relied on them being independent, then you could sort of select those data out.
That's true. It's just that if you select the data out and you're comparing, you have holes where the data. So
I understand.
Yeah.
Yeah. Right.
I'm a consumer of the bag files, and I'm very thankful for those being made available to help fishing and station fishing and that sort of thing.
Great.
Who chooses where to survey? Is that? It seems kind of random.
That's a great question. So Coast Survey's Hydrographic Survey Division a few years ago, started on a revamping of where to survey. So a hydrographic health model. I think one of the alums, Cassie, had done her master's on as part of it, but it's looking at like the health of the seafloor. So what is the quality of the bathymetry you have? What do you need? What's the risk if you don't survey that? And to help prioritize where to then send survey vessels and assets to collect additional data. Because it's not just where you haven't surveyed, but there's also the repeat, like where there's high risk if you don't have the newest data. Like you might have to go back and resurvey an area multiple times before you get, into location. So that hydrographic health model is in continuous research to then be available for the whole nation so that we have an idea of where to survey.
Well, following up on that, do you think NOAA would be amenable to receiving input from the community that says, look, we're seeing real discrepancies between what the chart shows and what we're seeing on our echo sounder?
So we have a system, right? Where you can input.
Is there?
Yeah,
There is, okay.
What's it called?
So surf requests, navigation managers are probably the best point of contact. So there's a regional navigation manager and they can help, like, okay, you have a polygon or delineate where those areas are and they can put a request in and either find an external source data that exists or add it to the, the prioritization list of where it needs to be put.
Can you go back to your previous slide? Your last bullet there, need to educate users to understand the metadata provided. It probably, yes, 102 probably itself. Do you think there's a role for the new NOAA Center being built to be a place to do that kind of education or educate the trainer type thing?
Yeah, and there's lots of different levels to educate on. I mean, certainly there's graduate students here, like that's one user that I think it's important to kind of understand these concepts. There's the mariner themselves. They're not necessarily going to the new center, but there are large training centers where they go and get trained and do exercises. But then, at the new training center, I'm sure that there'll be a place for people to understand the kinds of concepts we were talking about.
And just one other question. The concept of having the S102 and then the S104, the water level predictions. You have the uncertainty in the S102 product. The S104 by eventually have uncertainty in its prediction of the water levels. Do you think it's going to be a challenge on trying to use those two uncertainties to give what the uncertainty of the underkeel clearance is?
Yes.
Do we have another master's student or PhD?
If you'd like to have one, we could probably find one for you.
Just kind of a philosophical question here. I'm thrilled that you're displaying all this stuff. There's nice raster plots, which are supported by S102, I guess. Are mariners using that yet, or are they just still looking at contours?
A lot of the pilots are asking for us.
Yeah, I know the pilots.
Oh, you're talking about
Fishermen. That's great. I'm just thrilled. It's about time.
Yep. It's in use, but it varies regionally, and yeah, I mean, some of the training centers are just interested, and I think that will then percolate out as well.
In your, I have a comment really, but in your mission to educate users, I think it'd be important to not exclude people who are not mariners, but the general public who will use Blue Topo because it's such a beautiful data product for all kinds of other things. But maybe it will have profound implications for them knowing that portions of the data are interpolated and not just measured. And it would be good to have that clearly laid out, I think.
Yeah, we have some of it written out. It was written years ago at this point in the frequently asked questions section of our Blue Topo webpage. So we tried to at least put it somewhere. Maybe it needs its own page as well, but there's a specifications page that basically goes through and talks about a number of the different metadata items we discussed. And then there's a separate page that's frequently asked questions about how to use those values. So.
Just by the way, every 5 minutes or so, as you're looking at a full coverage plot, all of a sudden you see what the real coverage is. It scares the bejeebus out of you.
Yeah.
It is a changing culture though, because a lot of people have that same thing with rasters, right? They're like, oh, I got the new raster, everything's updated as of this date. And that's not true, right? There's a lot of our seafloor that has been mapped since like the 1800s.
One point of nuance that I have to admit, I got lost in your presentation even, is like the terms coverage and bathy coverage. Like mathematically, I'm like, well, one of those is a subset of the other one, like because I don't understand the term exactly as you intended, I think. And if that's the metadata that goes in the bag files or geotip or whatever, as a naive user, I would probably might misunderstand what is intended by that.
Yeah, it was a little bit of retrofit in terms of the terminology, because coverage is something that has existed in S57 forever. And so it was like, well, what does that mean? And certainly to coast survey, side scan is you have coverage there. So it's really like survey coverage is what that means. And so I think that then we were like, well, we want to know where the bathymetry is. So it's bathymetry coverage. So it just kind of developed. Maybe if we were to go back, there'd be better ways to.
Right, like systematic. That's just when we think of coverage, it's like, did you survey the seafloor in a systematic way?
Continue to evolve.
Well, I mean, it has evolved by going to the Blue Topo spec, which bled into the bag spec, which then bled into the S102 spec. And once it's in the S102 spec, it's kind of permanent. Like changing things with the IHO and those is somewhat more complicated. Yeah.
Okay. I know some of the surveys have hydrants data. Is that becoming more important, or is that sort of a like product?
And certainly the seafloor type is an important part of what we do, but that's more on the.
Depends on the user.
Yeah, but I'm trying to think of how that goes through the process. So we used to do a lot of bottom samples associated with our hydrographic surveys, and then they would, really end up on the chart as they but that doesn't really travel through the bathymetry pipeline in the same way.
I think more of the features.
What's that?
I think it's part of features, right? Don't they add it as a point feature in the area that you collected the sample?
It's just, but it's distinct from the kinds of features that I think we're talking about. It's not like feature detection true means you took.
No, it's the file, right?
Right.
For Steven.
Right.
He's smarter than I am.
Yeah, any last question? Yeah, but I think I have one. Thank you for the presentation. I noticed like you really emphasize on systematic, so like systematic surveys or like, so what happens when the survey is not systematic, like, you know, all of these kind of like data that you have, like, are you just ignoring those?
We're not interpolating. The data still gets used, but it's not interpolated. Yeah, so it goes into the compilation in that it's kind of presented to our algorithm to say, should this be used or not? And if there's better data there, it's not used. And if it is the best available data, then that's what's used.
That makes sense. Yeah, thank you. Let's thank them once again.